We're going to do B in your notes from day one. So I'm going to actually do it two different ways. We'll do it one way and then we'll do it another. And sorry about my Elmo. Sometimes it has struggles on finding the right camera, but hopefully it'll work this time. And it'll just pop up here in just a second. So I call these kind of logical puzzles. So hopefully if you like doing puzzles or Rubik's Cube or Sudoku, however you say that, you'll like doing these. So here we go. We're going to logically kind of think through some things here. We're going to start out, and again, I'm going to do B, which says we have tangent squared theta times the sine squared theta plus tangent squared theta times cosine squared theta. And we are trying to rewrite this using things that we know. And we're kind of putting together a logic puzzle to make this become something else. So if I were to ask you to look at that, and I were to say, okay, tell me some things that you know. And, I'm not sure. If you all were here, I imagine you would tell me some things you know. And I know you know a lot. But one of the things I think that you would know, or that I'm sure that you know of, is the fact that tangent squared theta is sine squared theta over cosine squared theta times sine squared theta plus sine squared theta over cosine squared theta times cosine squared theta. Oh, by the way, when there's not an equal sign, and we're just trying to simplify expressions, we shouldn't add an equal sign. So one of the mathematical symbols that we can use is an arrow, which means that it follows. So from here, it follows that I get to here. And I did that by saying that tangent is just sine over cosine, and so therefore tangent squared would be sine squared over cosine squared. So from here, where would it follow? Well, this one here is pretty easy to see, I think. This is over 1. If I'm multiplying and dividing, then what happens with multiplication and division? They divide the same thing as on top and bottom. They divide to 1. So I get 1 times sine squared. So over here I get plus sine squared theta. On this side, it's over 1. Nothing simplifies. So I end up with actually sine to the 4th theta. Or if you want, if you're kind of saying, I don't want to write that as sine to the 4th, you can, but you could just write it as sine squared theta times sine squared theta all over cosine squared theta. It's kind of like that. Yeah? Now, these two both have a what in. Now, you could, looking at this, you could say, oh my gosh, these two both have a what in them. They both have a sine squared. So it would follow. That's kind of a stretch a little bit, so that's why I'm here to help. Since they both have a sine squared theta in them, in mathematics we can do this cool thing. It starts with an F. It's called factor. So we can factor out a sine squared theta. That's going to be times our sine squared theta over cosine squared theta plus 1. If you think about it, if you were to multiply this back in here to here, you would get sine squared times sine squared, which is sine to the 4th, which is what we had written before, and then over cosine squared theta, and then you have sine squared theta times 1, which is sine squared theta. So they are the same or equivalent. So from here, then, it would follow that I could rewrite this as sine squared theta times tangent squared theta plus 1. Because sine squared over cosine squared is tangent squared. So then it would follow that I could say I have sine squared theta. Remember what we just said tangent squared theta plus 1 was? If you don't, look back at your notes. But it is secant squared theta. But wait a minute, we have another name for secant squared theta. Secant squared theta is just 1 over cosine squared theta, which this is over 1. So now by multiplication, it follows that we get sine squared theta over cosine squared theta, which of course you guys know to be tangent squared theta. So we just turned this into tangent squared theta. And there's our logic puzzle. It's kind of done, kind of cool, kind of fun. Some of you might be out there saying, not so fun. It's okay. Don't worry. We'll get the hang of things. Now, I told you I was going to do it two different ways, because sometimes, sometimes in life, like if you're hiking or if you're motorcycle riding or riding a mountain bike or running or whatever up a trail, you come to a crossroads, if you will, like a Y in the trail. And maybe you've never been on that trail before. You have no idea where either side goes. So maybe you go down one side. We went down a path. And it got pretty difficult. Right in this area, it got kind of rough. Not too bad, but a little rough. Sometimes when you're doing it, maybe you're on a Jeep and you're Jeeping. You go down this trail on a Jeep. The path gets so difficult, it's unsurpassable. Maybe there's a boulder there. And if you had a different Jeep, or maybe if you were with a very experienced Jeeper, they could get you over that path, kind of like me. I'm an experienced math guy a little bit, and so I was able to help us get through that little tricky part right there. Okay? Sometimes, though, you're on your own and you don't have that experienced Jeeper or experienced math guy, and you're like, wow, what do I do? Maybe you get to a point where you're like, I can't go any further. I don't know what to do. If that's the case, maybe you have to go back to the beginning of the trail, pick the other way. So let's come back up here. Okay, I'm going to do this a second way. Here we go. And we always try to learn from knowledge that we gain. So maybe we came down this path. Maybe I helped you out here. Maybe you get this problem again sometime later, and you're like, okay, I'm going to try to learn from what I've done in the past. Right here, in this step, if you remember correctly, we talked about in mathematics when two things are the same, with an addition or subtract sign, two things are the same, we can do this cool thing called factoring out. We factored out that sine squared theta. Well, if I look right here, I notice, or take note, that I have two things that are exactly the same, with an addition sign between them, so I could factor it out. Tangent squared theta times sine squared theta plus cosine squared theta. Now, folks, I'm going to tell you right now, if there is one Pythagorean identity I want you to remember, one, it would be that sine squared theta plus cosine squared theta equals 1. Please, 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 please put that to memory. Sine squared theta plus cosine squared theta equals 1. So then it would follow I get tangent squared theta times 1, which leads me to tangent squared theta. Which, if you notice, that's exactly the same thing we got here. It just was a lot easier. Sometimes that's how it happens, folks. Sometimes you take a path, it gets difficult, come back, try a different path. Sometimes you pick the right path and it's really easy. You still can get to the same place and see the same things, just some are a lot difficult. Okay, hope that helps, and we'll talk to you later. We'll see you guys. Have a good one. Bye.